Hello everyone, this is Shrawan Sir, making maths simple for you. Welcome to my YouTube channel, Karna Maths Academy. Today's topic is Principle of Mathematical Induction. Dear students, in the previous video, already we have discussed 6 important problems related to the Principle of Mathematical Induction. Now we are going to solve next important question, which is also from Principle of Mathematical Induction. Dear students, the question is, using Principle of Mathematical Induction, prove that 1 plus x whole power n is greater than or equal to 1 plus nx for x greater than minus 1. Dear students, here we are given a statement and we have to prove it by using the principle of mathematical induction. Here we go. Dear students, according to the principle of mathematical induction, in order to prove the given statement is true, at first we have to prove that the given statement is true for n equals 1. Then we assume that the given statement is true for n equals k. And by assuming that the given statement is true for n equals k, we prove that the given statement is also true for n equals k plus 1. And finally, we conclude that the given statement is true for all the natural numbers n belongs to n. So there are mainly 3 steps to prove any statement by using the principle of mathematical induction. There are mainly 3 steps. First, we have to prove the given statement is true for n equals to 1. Then we assume that the given statement is true for n equals to k. And by assuming that the given statement is true for n equals to k, we prove that the given statement is also true for n equals k plus 1. So dear students, the problem is very simple. So let's solve it. So at first, we suppose the given statement as Pn. Solution. Let Pn be the given statement. Let Pn be the given statement. So dear students, the given statement we are supposed as Pn. Therefore, we can write it as Pn such that 1 plus x whole power n is greater than or equal to 1 plus nx for x greater than minus 1. For x greater than minus 1. So dear students, according to the principle of mathematical induction, at first we put value of n equals 1. When n equals 1, let us see whether the given statement is true or not. So dear students, in the left hand expression we have got 1 plus x whole power n. So we are going to put the value of n1 greater than or equal to 1 plus n means 1 times x. This implies 1 plus x whole power 1. Simply we can write as 1 plus x. Dear students, which is greater than or equal to 1 plus 1 into x, we get x. So dear students, if we look at the left hand expression and again if we look at right hand expression, then we have got both equal. 1 plus x is equal to 1 plus x. So we can say that the given statement is true for n equals 1. So let's write on the conclusion. It shows that, or we can write, therefore it shows that Pn is true for n equals 1. So if we put value of n 1 in the given statement, then it will be P1. So we can write, it shows that P1 is true. The given statement is true for n equals 1. Dear students, now the next step of the principle of mathematical induction is, we assume that the given statement is true for n equals k. So let's assume it. We assume that let us assume that Pn is true for, that means our given statement, Pn is true for n equals k. So dear students, now we'll put the value of n k in the given statement, then it will be pk, such that 1 plus x power n. So n value we are going to put k, so we get 1 plus x whole power k greater than or equal to 1 plus nx. 1 plus n, n means we have taken k, 1 plus kx. So dear students, we have put the value of nk in place of n. Simply we have put the value of nk, so we have got 1 plus kx. For x, the condition is for x greater than minus 1. Dear students, the condition is for x greater than minus 1. So dear students, now let's suppose this as I. Now by assuming that the given statement is true for n equals k, we are going to prove that it is true for n equals k plus 1. Now we are going to prove that the given statement is true for n equals k plus 1. We show that Pn is true for Pn, that means our given statement is true for n equals k plus 1. Therefore, so let's put the value of n k plus 1 in our given statement, then it will be p k plus 1, such that 1 plus x whole power n. 1 plus x, n means we have put the value of n k plus 1 greater than or equal to 1 plus nx. n means we have put k plus 1 times x. So dear students, in our given statement, simply we have put the value of n k plus 1x. Now we are going to prove that this statement is true by assuming that the given statement is true for n equals k. So dear students, now we are going to use, we have supposed that the given statement is true for n equals k. So we are going to use this statement, and we show that it is true for n equals to k plus 1. That means we'll show that this expression, or we can say this statement, is also true. So by 1, let's write on by 1. By 1 we have the statement. Let's write down the expression of left hand side and the right hand side. 1 plus x whole power k is greater than or equal to 1 plus kx. 1 plus kx. So this means by 1, our statement is 1 plus x whole power k is greater than or equal to 1 plus kx for x greater than minus 1. So already we have assumed that the given statement is true for n equals k. So we can use it, and by using it we are going to show that the statement pk plus 1 such that 1 plus x whole power k plus 1 is greater than or equal to 1 plus k plus 1 times x. So dear students, now first we are going to make the expression of the left hand side same as 1 plus x whole power k plus 1. So dear students, we have to prove that 1 plus x whole power k plus 1 is greater than or equal to 1 plus k plus 1 times x. So we need, first we'll focus at the expression of the left hand side. We need 1 plus x whole power k plus 1. So let's do some calculation in the rough. So we need 1 plus x. We need the expression 1 plus x whole power k plus 1. So if we break down it, then the expression will be 1 plus x whole power k times 1 plus x whole power 1. So this means the expression 1 plus x whole power k, we are going to change in the form of 1 plus x whole power k plus 1. That means we need 1 plus x whole power k times 1 plus x. So 1 plus x whole power k already we have got. 1 plus x whole power k already we have got. Now we need another term which is 1 plus x power 1. Then after multiplication only we'll get 1 plus x whole power k plus 1. So dear students, so we need 1 plus x. So we need 1 plus x. So let's multiply the left hand expression and right hand expression both by 1 plus x. So multiplying by 1 plus x on both sides, then our expression will be 1 plus x whole power k times 1 plus x, and again multiplying the right hand expression also by 1 plus x. So dear students, now we'll focus only on the left hand side at first, because we need 1 plus x whole power k plus 1. So dear students, now if we multiply, dear students, if we multiply 1 plus x whole power k with 1 plus x power 1, then we'll get 1 plus x whole power k plus 1. So the base are same. So according to the multiplication laws of indices, if the base are same, then we can add the power. So the product of 1 plus x whole power k and 1 plus x, we have got 1 plus x whole power k plus 1. So dear students, exactly we have got 1 plus x whole power k plus 1, which we need to prove. So already we have got the expression of the left hand side. Dear students, now the expression of the right hand side is 1 plus k plus 1 times x. So now we'll only focus on the expression of the right hand side. So let's copy 1 plus kx times 1 plus x. So dear students, now the expression of the right hand side we are going to change in the form of 1 plus k plus 1 times x, which we need to prove. So now, so we need manipulation, we need certain tricks in mathematics which is called manipulation. So dear students, So I need, dear students, we need 1 plus k plus 1 times x. So whatever we have got, so let's multiply it at first. Let's expand it, then we'll make the plan. So 1 times 1, we get 1. 1 into x, we get x. Kx times 1, we get kx, plus kx times x, we get kx squared. So let's do multiplication at first. Then, dear students, we need 1 plus k plus 1 times x on the right hand side. So dear students, we have to focus what we need. So let's forget what we have. So let's forget what we have. So we'll just focus what we need. So this is the manipulation, this is the trick. So I need 1 plus k plus 1x. So I'm going to copy this expression over here. So I need the expression 1 plus k plus 1x on the right hand side. So the same expression I have copied over here. So dear students, now we have to balance all these terms with the terms of the above one. So this must be balanced with this one. Then when we can write equal sign. So let's balance it. 1 is already balanced, the first term. K into x, kx is also balanced. So let's take it. So 1 is already balanced. This term is already balanced. K times x, we get kx. So this kx is balanced with this x. 1 into x, we get x. So dear students, all these three terms are exactly equal with, or we can say exactly same as 1 plus k plus 1x. So dear students, now the remaining extra term is kx squared. So whatever we need, that means the expression of the right hand side, simply we copy and write it over here. Then the terms what we have, we just balance with the previous one, and the remaining terms we write at the end. So dear students, so this type of process is called manipulation. According to our need, we manage, and again we just balance it. So dear students, now we need the relation greater than or equal to. So again what we have, we just damn care, we don't look at it. Again we copy this whole statement with this relation, that is greater than or equal to. So dear students, now let's copy this whole expression again. Greater than or equal to 1 plus k plus 1 x. So simply we have copied over here, and let us see whether it is eligible, whether we can write it or not. So 1 plus k plus 1x, so both these are balanced, and we have got one more extra term. So this whole expression, from this whole expression, simply we have written the first and the second term. So this whole expression we can easily write down greater than or equal to 1 plus k plus 1x. So dear students, so we know that whole thing is always greater than its components. Any whole object is always greater than its parts. So 1 plus k plus 1x plus kx squared, this whole expression we can write greater than or equal to the first expression, because x is already square, x is already given greater than minus 1. So this whole expression we can write greater than or equal to parts of this expression, that means 1 plus k plus 1x. So dear students, so in this way we have got 1 plus x whole power k plus 1 greater than or equal to 1 plus k plus 1 times x. So now we can say that the given statement is true for n equals k plus 1. So let's write down conclusion now. It shows that, so let's write down the conclusion. It shows that pk plus 1 is true. Pk plus 1 is true when pk is true, because by assuming that the given statement is true for n equals to k, we have proved that it is true for n equals k plus 1. So when pk is true. At last, dear students, let's write on the final conclusion of the solution according to the principle of mathematical induction. So dear students, now according to the principle of mathematical induction, we can say that the given statement is true for all the natural numbers n belongs to n. Hence, by the principle of mathematical induction, by the principle of mathematical induction, Pn is true for all the natural numbers n. N belongs to n. So dear students, So dear students, you can also take the screenshot of the solutions. Dear students, according to the principle of mathematical induction, at first we have shown that the given statement is true for n equals 1. Then by assuming that the given statement is true for n equals k, we have proved that the given statement is also true for n equals k plus 1. Hence, by the principle of mathematical induction, we can say that the given statement is true for all the natural numbers n belongs to n. So dear students, I hope that you have understood the solution of this problem, which is by the principle of mathematical induction. In the next video, again, we'll meet with a new content. Thank you. Thanks for watching this video. Till then, bye. Have a nice day. Thank you.